Hello, everyone. My name is Kirk Ulmer. I'm a weed scientist with the University of Delaware, and today I'm going to be showing you some of our watermelon trials for the Northeast IPM Center. In particular, this trial is looking at how we can utilize cover crops in between the rows of plastic to suppress weeds and improve soil health.
Weed control between the rows of plastic mulch can be challenging. Weeds are primarily controlled by herbicides, cultivation, mowing, or hand weeding. However, due to wider row spacing, herbicide treatments may lose efficacy before vines effectively cover the soil, and additional management tactics may be required. Grass cover crops such as cereal rye have been shown to provide weed suppression in agronomic crops such as soybean. However, cover crops are often planted in the fall, giving them plenty of time to grow before summer annual weeds start to emerge. In this study, we are evaluating whether or not spring-seeded grass cover crops can be integrated with other tactics for weed management between rows of plastic. Plastic was laid 4 weeks prior to transplant, and 5 different cover crop species were hand-seeded and raked in within 24 hours of laying the plastic. In addition, dual magnum was applied 2 weeks prior to transplant in order to reduce competition with early emerging weeds. To prevent cover crop interference with watermelon vine growth, cover crops were terminated with Select Max 4 or 6 weeks after transplant. Annual rye was seeded at 31 pounds per acre and accumulated between 400 and 700 pounds of biomass per acre prior to termination. Cereal rye was seeded at 120 pounds per acre and accumulated 300 to 600 pounds of biomass per acre. Spring barley was seeded at 125 pounds per acre and accumulated 1,500 to 1,600 pounds of biomass per acre. Spring oats were seeded at 138 pounds per acre and accumulated 2,000 to 3,500 pounds of biomass per acre. Sorghum Sudangrass was seeded at 49 pounds per acre and accumulated 200 to 300 pounds of biomass per acre. By incorporating cover crops with a pre-plant dual application, all species except Sorghum Sudangrass reduced early season weed biomass 90 to 97%. However, this tactic alone did not provide full season control. Weeds that were present at cover crop termination were able to grow up to harvest. While spring-seeded cover crops provided early season weed management in row middles, further research is being conducted on how this approach may be incorporated with other weed management tactics for full season control.